Okay, so here in Chapter 8, and here we're going to do 8.1 and 8.2 together. But what we're looking at is hypothesis testing with two samples. So what we did previously in Chapter 7 was looking at one sample. We had one sample, and we were trying to make a determination about the population from the one sample, and maybe we were trying to say what we believe the mean to be, and we were testing that. So what we're trying to do now is we're trying to compare two samples and the population and some statistic, some parameter that goes along with the populations for each of those two samples. So that's what we're going to be looking at here, two samples instead of one. So the first thing that we have to look at is actually some things that are involved in hypothesis testing with two samples, some things that are going to be new, and then some things that are going to be very similar to when we did it with one sample and are similar to any type of hypothesis testing. Okay, so let's take a look. So the first thing is determining whether the two samples are independent or dependent. All right, so we're going to have to take a look at what that means and how we can decide whether samples are independent or dependent. So that's going to make a difference on how we study them. Then we'll do an introduction to two-sample hypothesis testing for the difference between two population parameters. And we're going to look at the difference between the population means, mu. So then specifically, we're going to go into testing the difference between means when we have independent samples and our population variances are unknown. And we're going to do dependent samples where our population variances are unknown. So I'm not going to do the case where the population variances are known. I want to stick with what the more common occurrence is when those population variances are unknown, and in the cases where we're using independent samples, and so that's going to be section 8.2, and when we're using dependent samples, and that's going to be section 8.3. All right, so the first thing really that we have to talk about is independent versus dependent samples. So what is an independent sample? Well, that's, as it sounds, when the sample selected from one population is not related to the sample selected from a second population. All right, so there's nothing linking the two samples, right? You have one sample from one population, you have another sample from another population. They can be different size samples. So there's nothing linking the two. That, if we had some sort of linkage between members of samples, that's when they would be dependent, okay? Or paired or matched. So that's when each member of one sample corresponds to a member of the other sample. There's some direct link between the members of the samples. All right. In a picture, it might look like something like here. So in the independent samples case, you have one sample that has maybe these 4 different members to it. And you have a second sample that has these 1, 2, 3, 4, 5, 6, 7 members to it. And there's no relation between the members of each sample. While in the dependent sample case, we have to have the same number in each sample, and there's a linkage. So this member here is somehow linked to this member here, and this member here is linked to this member here, this one to this one, and this one to this one. So there's a matching of those members. As we look at some examples, it'll become clear when you're dealing with independent and dependent samples. Let's look at some small examples here. So are these independent or dependent? All right. So if sample 1 were triglyceride levels of 70 patients, and sample 2 were triglyceride levels of the same 70 patients after using a triglyceride-lowering drug for 6 months. So the question is, are they linked? Well, yes, because we're looking at 70 patients there and the same 70 patients after using this drug. So there is a direct link where you're looking at the same people in kind of a before and after situation, which is very common to dependent samples. All right, so this is dependent. All right, so look at the other example. Sample 1 is scores for 38 adult males on a psychological screening test for attention deficit hyperactivity disorder. Sample 2 scores for 50 adult females on a psychological screening test for attention deficit hyperactivity disorder. Okay, so there's no link between the 38 adult males here and the 50 adult males there. All right, yeah, they're being tested for the same type of thing, but there's no link to these actual members. There's no pairing of a member from sample 1 and a member from sample 2. So this is independent. Okay, so basically, we're going to have to be able to identify dependent versus independent samples. Then that'll affect how we carry out certain aspects of the hypothesis testing.